the motion in each of these graphs. And we're going to use the clues in the graph to decide how the object is moving. So you'll notice in each of these graphs, there are 6 of them. They're all velocity time graphs. You can see that label. That's the first thing you should look for. Okay, so in the space provided to the right of the graph, you want to say whether the velocity is constant, increasing, or decreasing. It's going to be one of those 3 things. And you want to say whether the acceleration is negative, positive, or 0. Okay, so I'm going to do that for each of these things, and I'm going to abbreviate it so that it doesn't take up a lot of space. Okay, so in this case, let's look at this one first. The velocity here is a horizontal. Notice, and the velocity is not changing because it's horizontal. Then that means the velocity is really not changing as the time passes. So in this case, the velocity is constant. Okay? If the velocity is constant, if you think about the progression of graphs that we talked about earlier, if you have a horizontal, that will mean that the next graph, the acceleration graph, will be 0. If the velocity is constant, then the acceleration is equal to 0. Okay? So let's go to this one. Well, here, okay, the velocity is constant again, isn't it? Except in this case, here the velocity is constant, and I'm going to add something here. It's positive, right? It's a positive constant velocity, but the acceleration is 0. Here, it's also a constant. But in this case, the velocity is negative. Okay? You can see again, it's horizontal. Okay? But it's below the origin. It's below the intersection of the time axis and the velocity axis. So this is negative down here. Okay? So it's constant and negative. Well, if the velocity is constant and negative, well, the velocity is constant. The acceleration's got to be 0 again. Okay? There you go. Now let's go to this one. Now here, in this case, the velocity is a diagonal. Okay? But the velocity then, the velocity is increasing. I'm just going to write INCR, increasing, and it's positive. Okay? The acceleration then, since the velocity is increasing, okay, if I were to draw the acceleration graph to go with this, this would be a horizontal. This is a diagonal, so the acceleration graph would be horizontal. So the acceleration is constant because the slope of this line is a constant, right? And it's positive. It has a positive slope. This has a positive slope. So the acceleration is constant and it's positive. Okay? Okay. Okay, next one. Here's the velocity. Oh, here's another diagonal, isn't it? So the velocity is increasing at a constant rate, but it's increasing in a negative direction. So here the velocity is also increasing. The velocity is increasing, but it's increasingly negative. Okay, it's not decreasing, it's increasing. It's getting larger, but it's going in a negative direction. So in this case, since the velocity is increasing in a negative direction, this has a negative slope. Okay, so this slope of this line is the acceleration. Okay, so if you look here, for example, the acceleration is a positive because the slope is positive. Here, the acceleration is negative because the slope is negative. So here, the acceleration is going to be constant. This is a diagonal. So this is going to, the acceleration has to be constant. The slope of that line is constant. And it's negative. Okay? Okay, this one. Well, the slope of this is negative, but it's a constant slope, isn't it? So the acceleration here is going to be negative. Okay? So the velocity is actually the velocity is actually positive, right? It's actually positive, but because it's in a positive direction and it's decreasing, right? But it's positive. It starts at a relatively high positive velocity, and by the time this is over, it's at zero. The velocity is zero, so it's at rest. So it's going from a positive number to zero, so the velocity is positive, but it's decreasing. Okay, so this velocity is decreasing. Well, accelerate. This slope is negative, so the acceleration here is going to be negative. And since this is a diagonal, so the acceleration is going to be horizontal, which means the acceleration has to be and the slope of this line is constant, right? It's negative, but also constant. So the acceleration has to be constant. Okay, one last one. Okay, the velocity. Okay, the velocity in this case, well, think about it. It starts at a fairly large negative number and it ends at zero. So the velocity is actually decreasing. It's actually decreasing. Okay, but the velocity, notice it's always negative, and by the end of this, it's about zero. So the velocity is decreasing, but it's negative. Okay, now the slope of this line is positive. Notice that? So the acceleration is, okay, the acceleration is going to be positive, okay, okay, and this is a diagonal. The slope of this is positive and constant, so the acceleration is constant and it's positive. Okay, okay, there you go. Okay, got it? Okay.